Huh. That's kind of that's kind of interesting. I think that's the automatic 40-minute limited startup of the recording, because I hit the record button on the bottom of the screen. Yeah, I'm thinking that hopefully this works okay.
Yeah, I've never had it impose a 40-minute limit. I mean, we're on the paid account, so it shouldn't.
Well, but when what just happened, where it
Uh-huh.
just announced that was completely automatic. I didn't do that.
Right. Now I've
I
seen
didn't
that
hit
before though.
see. Yeah, but I've also seen that cut itself off at 40 minutes too, and
Oh.
it's like it. Well, I hit the start recording button here myself, so I'm hoping
Yeah,
recording to the cloud. So hopefully it'll. I hope it's working right.
we'll keep an eye on it.
Yeah. Okay. All right. Well, let's see here. There we go. Okay, roll into the clean screen there. Let's see. Okay, so you guys should all be, yeah. Okay, you're all seeing that. Well, welcome to the first meeting in 2026. Man, let's see. What are we at? Let's see. We are at let's see. This club started in 1982. And I don't know what month it started in 1982, but let's see. Here we are in 2026. So do the mental math there. How many years has this club been going on? Way longer than any of us want to admit, I think. So, welcome everybody. We're excited for the meeting today and the cool presentation. I'll tell you a little bit about when we get a little further along. Follow the usual agenda here and um, give a little bit of club business up front, and then we'll talk Robothon updates and that sort of thing, and then we'll go to some round the room sharing. Whoever's got something to show, and aside from the presentation, of course, that's just general information to share. If your microphone happens to be active, appreciate you going ahead and muting it unless you're actually actively talking. So that way we don't get the dog barking in the back or the cat meowing or the wife screaming in your ear or anything like that. So, and as far as on the present, particularly on the presentation, but also in just recording in general, because we're posting this to YouTube, it's important to don't share any proprietary information or anything that you do not want just going out on the web, because it's a kind of a pain to edit stuff like that out after the fact. I've actually had to do that a couple of times, and it's not fun. So thought I'd make sure that that's up front. Robothon merch store. Of course, this particular shirt here. Let's see. Oh no, you can't. Can you? Oh, wait a second. Am I over on the side? You seen? No. Okay. Yeah. So I'm wearing a nice. It's a polo shirt that we had done a number of years ago. Let's see here. Okay, I'll go ahead and let's see, how do we do this? And pin. There we go. Okay, yeah. So there's this is a really nice polo shirt. I like this. I like this thing. It's this was I don't know. I'm not sure. And maybe Lloyd, you could answer the question. Do you have any idea if they have polo shirts available on the merch site
Yeah,
for?
we do. Yeah, I
Oh,
think we
good.
could do polo shirts. They were a little more spendy. If folks, so on the merch site, if somebody sees some combination of something that they want, that's not showing, just ask. We can probably do it. The
Okay.
way that site works, you pick your artwork, you pick your thing you're printing it on, and when I went through, I just kind of picked the ones that looked good, right? It's not, there's more combinations available.
Okay. That's good to know. One of the things that, of course, is particularly cool about the way this works is that you can have SRS stuff put on just about anything.
Yep.
And so,
And just a
so
heads up. Oh, go ahead, Steve.
yeah, no, go ahead, Lloyd.
Oh, and just a heads up. There's stuff that that's available that I don't even represent on there because I'm not sure people want an SRS shower curtain. That is available. If you really want one, we can make it happen. There's SRS throw pillows. Um, oh, there's also cooking aprons. There's some stuff. There's a lot of stuff on there. So just about anything you can imagine, the combination can be put together. I went through with the ones that I think most people would want. If somebody really wants the SRS cooking apron, I can probably make that happen.
I bet there is something that's missing on there that you might want to consider this. Now, I don't know how many of you guys are familiar with Spaceballs and all of the crazy stuff that Mel Brooks did in that movie. The merchandising, his little, when he was playing yogurt and he was showing the merchandise there, and of course, one of the most popular items that he particularly liked was the Spaceballs flamethrower. So
that is not available per insurance regulations. I will also note we will not be doing flamethrowers at Robothon because of insurance regulations.
Oh, darn. I remember watching a behind the scenes video about that movie, and one of the things that I guess Mel Brooks and George Lucas kind of did a little back and forth, but George insisted that they not do Spaceballs merchandise for real. I mean, but Mel Brooks, being Mel Brooks, of course, he had to make sure that he kind of, tighten the screw in the movie by having all of the usual stuff, because I mean you get right down to it. So a lot of these movies, the amount of money that they make at the box office a lot of times pales in comparison to what they make on the merchandise. So anyway, that was I thought that was pretty funny, and it's like, yeah, and he made the comment he made was about the flamethrower was really popular with the kids. It's like. Oh yeah. That's oh yeah, I forgot to put my chat window up there. Flamethrower robot comet. Oh, okay. Yeah, yeah.
Flamethrower.
Yeah, the thing about something like that is you probably don't want your name on it because that creates a legal pathway back to you.
Oh, come on. Elon Musk did it.
Oh man. Yes. Bad things did happen, yes. Okay, next. I think I got this right. And if anybody can, if not, so let's see. So we're the 17th. So next Saturday, 24th. So I believe that's what I saw on Donna's meetup for the Build It with Arduino. The next Build It with Arduino meeting. So that's yeah, okay. Well, it's like I've got last Saturday, but I guess I'm not sure. So I didn't have a chance to check that here before the before the meeting. I should have done that.
That should be the 31st. It should be the last Saturday.
The last Saturday. Okay. So that is okay. All right. Well, I'll fix that when I post the slides. So all right. So anyway, Robothon. So I'm gonna turn this over to Lloyd. You can go ahead and give us any updates on Robothon.
Okay. So we're still in the planning cycle at the moment, but let me just qualify this. Everything I say is subject to change. We are still planning. What we are looking at this year is doing one big event in the summer in combination with WAR. So we're going to get back together with WAR. It looks like this will be in Seattle. We have a potential venue set out there. We're looking at August 22nd. is the date.
Mm.
So that'll be a little later. Plenty of time to build bots. I think next Friday is the date the committee's meeting. So by February, we'll have all the contests and stuff, nailed down and, have things a little more pinned down so we can tell you what to expect this summer. But kind of expect one big event. It'll be an indoor only event in Seattle on August 22nd. So we'll be looking at, events. Again, not saying this officially, but events, line following, line maze, sumo, pop can challenge. We probably won't be doing Robothon or Robo Magellan. Build challenge 1, 2, and 3, where we've tweaked the rules slightly so they're more obviously can be done indoors. So we'll have that up very shortly. By the way, flamethrowers will still be prohibited. It's a nice venue. We don't want it burned down.
Okay.
That's kind of where we're at.
Okay. Thank you, Lloyd. All right. Some of the resource pages on the SRS website there, you can visit these, and of course you can Google search maker spaces and that sort of thing too. But there's a couple of new items that I've added to the resources page this week when I was in there editing. So check those out. They're bold. Flamethrowers are also, check out Survival Research Lab YouTube. Oh, okay. All right. That's good to know. Thanks, James. Chris. Thanks, Chris. Soliciting presentations. Robert continues to send me many. So I sent out a handful of invitations this week. I don't currently have anybody for March, so that I might, depending on whether or not somebody slides into that slot, we may do a facilitated discussion that month. I have a bunch of them that are just kind of sitting out there waiting to be done. There's also lots of things from the past too that we could bring up again, or take even meetings that have things that have happened at meetings prior to when we started recording them. So there's all kinds of possibilities there. So, but in any case, feel free to send me information, contact information for anybody that you see out there that you think might be interesting. And of course, if you've got anything yourself to share, we would love to hear from you. And I'll work out the actual arrangements, but you're welcome to invite them to talk to us and tell them a little bit about us and what we do, and we'll see where that goes. So. Some of the potential topics that we might consider. I think that there's certainly lots of things connected with AI now that we might consider discussing. As you start looking at AI being introduced kind of in the back end of various realms. So it provides information collection, interpretation, processing, and then like in medical diagnostics, for example, using letting AI suggest things based on symptoms. Vibe coding. Let's see. Somebody that could talk about that, Lloyd?
I'm throwing it out there for two things. It's a topic that is popping up in our programming clubs, Northwest C++ and Rust. Mm-hmm. And we've done a couple of talks on it. But it's also one I'm kind of interested in and experimenting with, so I might do a talk on one at some point. But I just throw it out there as an idea to capture, because you were kind of in the AI, and that's kind of the hot thing right now, is how do you do it? How do you set the tools up? what are the risks? What are the advantages? Just something throwing it out there for ideas, and maybe if
Yeah.
something crops up, that'd be great. It's one I'm both experimenting with and looking for sources for. So.
Okay. Well, that sounds like I have a full. Wow. You want to do a talk, James?
I could be talked into it. I don't. The the problem is usually when you're doing a talk, people want you to have answers, and
That's not happening in this space right now.
yeah, it is quite. What the hell? Sorry. It's a very difficult time, and what I have is I have a bunch of data. I mean, you can look through the presentation. I have a bunch of data from the past and sort of just interesting things that I've come across. And I have there's two parts to the presentation. The first part is just about human worth versus rapid automation, and the one conclusion that I try to make in there is that it has nothing to do with automation replacing jobs. That's not the point. It's about the pace at which automation is replacing jobs. It's happening so fast that the rest of us poor SOBs can't possibly keep up with it. And then the second whole half of it is about AI safety. And that I think is the more interesting one, because there's this thing called the alignment problem that is really, really difficult to solve. And it's one of those kind of things where we're kind of out of time already to solve it. And so it's really kind of, there's kind of two presentations in there. One of them is relatively short, and the other one could be really, really long because it's about this AI safety thing, which is a super, super, even more complicated topic. And then the problem with that second one is that not only do I not have answers, but we're out of time for answers, right? Like it's not coming like a freight train. It's here. And although I hear this argued all the time, at least the modified version of Moore's law is absolutely holding. Computing power basically doubles every couple of years. So I'm already, I'm looking for a job that provides better healthcare than the one that I have right now, and because I'm working basically contract, and getting healthcare is becoming a real serious issue. So I'm looking for a better job. In the interviews that I'm doing, people are asking me. We went from, "Hey, you don't use AI, do you?" to, "Hey, you use AI carefully, right?" To, I mean, I just had the other day, they were like, "We're really not sure if we're actually going to hire somebody because the AI seems to be just doing this for us pretty well." And that's over the course of like 6 months.
Wow.
My friends who are EEs, they're not being impacted by this. Gemini and Claude and a couple of others can't draw a schematic to save their lives. I mean, they're non-lives. I mean, they just come up with absolute junk. But firmware programmers like me, old whitebeards, we are about to go the way of the dodo. If you're young, do not go into firmware. Do not go into low-level programming. Do not go into, somebody vibe coded an entire OS and posted about it. And the commentary was all basically, yeah, it's still better than Microsoft. So.
Oh my
That just
goodness.
says the bar is a little too low.
Yeah.
Anyway, it's a rough time.
Yeah. Yeah, for sure. All right. Oops. Okay, well, I'll chat with you, reach out to you later, James, and we'll work out when be a good time for you.
Sounds good.
All right. Let's see here. All right, back to business. Okay. Whoops. Oh, okay. Coming up in a little bit later will be Craig Austin's going to talk about his autonomous mower, and then maybe give us some teasers on his scotchbroom puller project that he's got out there, but hasn't quite got that guy ready to go yet. But sounds like both of those would be kind of interesting. So we're looking forward to that. And next month, Lloyd will be giving his presentation that he wasn't able to give us last October due to technical difficulties with the Zoom on choosing the right programming language. And then, like I say, all the rest of the slots, as you can see, are open. So any of those look good, I would love to start filling those in for this year. And of course, just a general information, the Zoom link. We do not intentionally change the Zoom link month to month, just because that keeps things consistent and makes my job easier. And that's part of what kind of screwed things up. And when we last October there, and our meetings got lost. And when you create new meetings, you in Zoom, you do not get to reuse meeting numbers. I'm not aware of any way to make a meeting using a meeting number that's already been used. It's just Zoom just doesn't allow you to do that. You can have the same passcode, but you can't have the same meeting number. So I'll try to get the post out this week for this meeting, YouTube video and slides and the chat text and all of that stuff. And of course, if you got any feedback for me, please just send it to the SRS Gmail. And let's see. Okay, so coming up a little bit later is Craig's going to be sharing with us about the that's orange or red. I'm not sure. It looks red on the screen there. Depending on the pictures, I'm looking at two different monitors here, and it looks orange on one monitor and red on the other monitor. So I'll just I'm sure the color of the machine is not the most important aspect of this machine. So
it's red if there are any doubts.
Okay. And then the autonomous scotchbroom puller. So I'm guessing that's currently a manually operated machine on the right there, and you're working towards automating that. So
yeah, we'll talk
about that. Okay, that sounds like fun. And just for anybody who's looking to go green here, there's a cyber buggy, and it occurred to me, though, as I was thinking about this, that it's not exactly zero emission because of what it turns horse oats into. So, but it's close. So, all right. So we've finally gotten to the around the room, around the web. Appreciate anything that anybody would like to share. And I'm hoping that you guys have got something that you've been working on that you'd like to share. I do see a couple of names that I'm not familiar with. I wouldn't mind just hearing a bit from you guys. Stephen, go ahead.
Hey, my name is Stephen. This is my first time coming to a meeting. And hopefully I've got a working robot for everybody.
Cool. All right. So you're You're being featured. Nice.
Yep. And here's how I am controlling it. I don't know if you
Okay.
guys can see it.
Yep.
Let me run it around a little bit.
So, all right. So you got to tell us a little bit about how you're doing all this.
Okay. So let me show you inside. So I don't know if you guys can see that, but it's a differential drive. So it's got
Okay.
two motors powering each of the 10-inch pneumatic tires.
Mm-hmm.
It's got a 12-volt SLA battery. And it's controlled by an ESP32 that's running its own web server.
Huh. And the app on your phone, is it, did you write that?
Yeah, so that's actually not an app. The ESP32 is running a web server, and I'm just open up a Chrome browser and go to like 168 dot
Yeah.
yeah.
192, 168. Yeah. Okay. So your local browser. And
Yep.
then,
So the ESP32 is actually running its own hotspot. So I don't need any Wi-Fi. So the cool thing is I can just put this thing in my car, take it to the park, and drive it around.
hmm,
Yeah.
how far away can you control it when you're
Oh, so I've been about 100 feet. The programming on it is not great. I did it all myself, all vibe coded, like you guys were talking about earlier. Um, and if I do lose signal, it just goes full speed ahead.
Yeah.
And this is
You
one
might
of
have to work something out on that fail safe there.
this is one of the
Just
issues of
ask
vibe coding.
Gemini how to fix that. I'm sure it'll be able to do it.
This is actually all ChatGPT 5.1 and 5.2.
So ask ChatGPT. I'm sure it'll help you out there.
Yeah.
Okay.
Well, it sounds like you could have some fun. You've taken that thing to the park and you sit in your car and you just put your robot out there somewhere and you just sit there and kind of drive it around and, see how people respond to that.
Well, so there are two different responses. If people know that I'm teleoperating it, it's a completely different response than before they see me. They think it's autonomous and they're like,
Yeah.
whoa, is this thing, thinking on its own? But no.
It's just, the robot wanted a little fresh air and a, nice little trip around the park. I mean,
Mhm.
what's the matter with that?
Yeah. Yeah, I can do about 2 miles. So I've taken it out on some pretty serious walks.
Cool.
Yeah.
Wow. Well, that's really cool. Yeah. Thank you for sharing that.
Yeah. Thank you.
Yeah. All right. Anybody else? I see is it Jarrett Seiler? I don't recognize your name, so I'm curious if you'd introduce yourself. You don't necessarily have to have anything to share, but we'd love to meet you. Assuming you're sitting close to your computer. Yes. He may be a stepped away there.
I got something I can share, Steve.
Okay, go ahead, Chaz.
Good morning, unless you don't live in the Pacific Northwest. Uh, as many of you know, I have a series of robots. They're all called the Muppet class robots. And so, like, here's one robot, doesn't much matter, but they're all essentially have the same core of controls. So it's 6 nodes of controllers. This is like a sample node right here. It's just an Arduino Adafruit RP2040 with a integrated CAN bus because all the nodes are connected by CAN. Um, and so it's got a main controller that you know basically it's not quite subscribes, but it listens for messages, and if they're there, then it can operate, right? So like here's a little LiDAR, right? And then it's got its little CAN node here, or CAN interface. So it takes the LiDAR information and breaks it up and then publishes it out at like 5-degree increments so that I have I can tell like if there's anything close to the robot, if it needs to back up or if it can continue moving on. All of that information goes across the CAN bus. And on all four robots, I have a Raspberry Pi, and the Raspberry Pi, of course, they have Wi-Fi, the little Pi Zeros, and then they talk back to a little, through a wireless router, these little ones that come out like that. And then this has connected to this is a Raspberry Pi 5. And what I do is I have a CAN bridge. So I take from CAN, I publish it on MQTT, which is a protocol. And I think I once talked about it, and I could have another talk about that because that's like an hour-long talk, just what is MQTT and how we use it. But the fun thing is I take all that and I record my entire session, not like, the motor is going this speed and that speed, but like the semantic data. And so I'm going to share my screen and share with you like how I record. Because as you guys remember, if you've been to any of the PopCan Challenge competitions, do I want this one? Yeah, sure. Sometimes your robot like just starts doing something. You're like, what are you doing? Like it just starts, going to the right, and you don't know like is it wanting to turn to the right? Is IMU data wrong? And you can like carry a laptop around behind your robot with a USB cord and like look at a serial terminal or whatever, right? But
Hmm.
I built this website because it's really just it's a black, well, it's what it says. It's a robot black box, and anybody could technically use it. Like, not technically, anybody can use it if you guys want to. So it has an API, so that Raspberry Pi, when it can connect to the internet, it buffers everything until it can connect to the internet, and then it uploads it to this black box archive, and it's semanticeventdata.com. And so the idea is you would like register, sorry if I'm getting quiet, register your robot. What is it? And then you have an API that you would program your Raspberry Pi to upload with some sample code of like how you upload the event data. And then just to show you like the reason I have this, and it's kind of related to the vibe coding. That's why I'm showing it to you. Here's the robot that I just showed you. It's the only one of the four right now that uploads. So here's its information, and I can view its runs, and I can just grab whatever one of these, view all events. And so it gives me all this data, which isn't super human friendly. It's not bad. But then you just come over to ChatGPT and you just go and control V this in here, and ChatGPT will churn on it and tell you like what's going on. And so it says, abort requested. Why? Because of mission fault. It's not random. And it just gives you like a rundown of what the event was. And the whole idea is you wouldn't want to dump, or it's hard to dump like, like a ROS bag where it's like 14 megs of data. You could never look through that yourself. But if you're looking for, what happened or what's going on, it gives you a good rundown. And it's just because it's just the important stuff. Like I've transitioned to wall following, and I stopped because the wall's no longer there, and that was expected. And so it's just gives you mission start, false, node, outcome, timestamp, et cetera, pose. But yeah, I think if you ever find yourself needing logging, and I've mentioned this before, probably years ago, like if you're building a robot, even if it's just a simple Arduino Uno or whatever robot, man, I can't tell you the importance of logging and understanding what
Hmm.
your robot's doing, because you can guess at it, but then you're just like blindly like, well, I guess I'll change this and see if that changes. And like having to iterate so many times. But if you go and collect like both my motors are going this speed, right? And at this whatever, and I believe I'm going this direction, and my target is this. And if you can record that somehow, even if it's on SD card or whatever, being able to like go back and look at like what your robot did so that you can like change it to fix it, especially like if you attend any of the competitions. Generally you only have like 20 minutes or so between the runs, And I mean, if you're like me, you probably procrastinate a lot and you're finishing up some final touches, or you weren't able to test like in that environment. So you want to test run it and say, well, how did it go? Okay, what do I need to change to make it work in this environment? Around this lighting or whatever it is. Logging data on your robot is crucial, and you could do ROS bags if ROS is your thing. But I find like this semantic data to be a little bit more valuable. But yeah, it's just like a free website if you guys want to use it. If you want to enter your robot and log your data, you could probably you could probably just point ChatGPT at this API and have it churn it out because I gave you some sample code on how to upload. You do need to register your robot so that you get a a primary key, and then it uses like the lightest authentication ever because I'm not really worried about like spammers or anything, I guess. I mean, I'm not. But I also don't want robots, recording on top of each other's data. The goal here is to really collect a lot of, hopefully, some researcher can use this um, to collect a lot of robotic run data. I think there was a recent, I can't remember what it was. We recently watched one of our past like presenters was talking about AI and grabbing semantic information to determine like what's what's your robot doing and how could it run better or that I can't remember the pair's name, but it's definitely on the YouTube video if anybody's
Okay.
interested. Yeah, that was it. It was just it's kind of a neat thing if you want. You're certainly welcome to use that. I mean, I built it for me. I have no intention to stop using it, but I figure if I can churn out some information for applied robotics or whatever, then that's awesome. But yeah, that's my share.
All right. Thank you, Chaz. Could you pop a link to that website into the chat there for me?
Yep.
Okay. It looks like Jarrett Seiler is. He says, look like he's up to introducing himself. Jarrett, go ahead. Tell us a little about you.
Hey guys. Yeah, thanks. This is my first meeting, and I haven't really done a robotics club before since like middle school. So, but I went through college and I saw that they had one, and I was kind of going the mechanical engineering route, and I did like Hyperloop, if you've heard of it.
Mm-hmm.
And now I'm thinking, oh gosh, I should have done the robotics club because when I got out of school, I went into design engineering, structural engineering, and I was like, gosh, I kind of miss robotics. So a little nervous, but I've been working on a project. I did a little bit of problem solving to do with working on a car. And as you know, if you've worked on vehicles before, you always lose your 10 millimeter socket. And so I've always been losing my sockets and whatnot while working on vehicles. And so I thought, well, a bit of robotics could help with that, I guess, if you were to integrate some automation with your socket storage device. So let me switch here. Hello.
Hey, yeah.
Let me rotate. All right, so it's a bit messy, but what I have here is like a socket rotational assembly. And with a NEMA 17 motor, it rotates kind of like an assembly line. What I have here is a light, and then I have a photo resistor down here.
Okay.
And so the purpose of it, let me actually, well, basically the light.
I know what this is. This is like one of those automated tie racks, but for sockets.
Yeah, pretty much.
I love it. This is great.
Thanks, man. So yeah, basically it goes by and the light gets blocked by the socket. I could start it up, but you can see my breadboard is pretty messy, and I moved it in from the other room because we have family visiting. So I kind of got some wires pulled out, but
Oops. That's all right. Hey, what do you need sticking wires for?
true, yeah. Just rotate it by hand, right?
Yeah, yeah.
But anyway, the socket goes in front of the light, the photoresistor value goes up or down. And then it can tell based off of the width of or the amount of time that the socket has been blocked based off of your speed value, what socket you're at. But you have to do a full rotation once to kind of get like all the values, and then you take the widest portion and you correlate that to the 17 millimeter. So I'm working on the Ross right now, but the purpose of it is to be like, oh, okay, I want a 3/8, and you got this microphone right here. So I just repaired. Oh, here it is. I just repaired my Pi. I worked at a part-time job where I was doing like some technical work, and I got this Pi, and the SD card slot was a bit messed up, so I got a soldering tool, and I ruined the resistor that was down here because the soldering tip, of course, it's like the size of this pencil. So one of my first time soldering, and it still turned on, and I could still connect to it. So I'm like, okay, cool. So I got this Pi that's going to be running with the Arduino, and basically that'll be running the voice command, and then it'll be doing the voice parsing and sending that out. And then when you say, like I said, I'm still working on the programming for it, but you could say like 16 millimeter. And so the purpose would be to have it come out here, and then you have them facing it so that the 3/8 drive is up, so that you can just snap it in there and take it out. And then basically I'll have it on a timer, and you would say like the next one. And I don't know if I'll have like confirm you put it back or whatnot, you know, because if you just keep taking them out, what's the point of inventory? Because you wouldn't have them anymore until, of course, eventually all the way around. Oops. I'll like pull more wires out. Anyway, that one's missing. So then it would be like, oh, okay, like one's missing, like stop and replace. I don't know how I'll do the inventory management, but maybe I'll just have it run one time around to make sure that you put everything back. Another cool thing I was thinking about doing was having, so I have an adapter. Oh, I don't have it in there. Like a 3/8 to 1/4 drive.
Right.
And so if you have a small enough millimeter socket, I think I go down to, or I go down to 1/4. So it has both like imperial and metric. And I just kind of took like the 16 most like used sockets, most common sockets that I work with. So if you have a 1/4, my plan is to have it go to the adapter first, so that it's like the primary tool that you're using is a 3/8 drive. And then it would pull you to the adapter. So if you said 1/4, it'd go to the 3/8 to 1/4 drive adapter first. You would snap that on, and then after 5 seconds or so, it would go around and it would give you the 1/4. That way you can just, not have to worry about grabbing your other 1/4 drive socket wrench. Yep, that's what I'm working on.
That is pretty neat. Yeah, for sure.
Yeah, all of it's 3D printed. I have my Octoprint working right here.
Nice.
Yeah. Appreciate you guys letting me share.
Yeah.
So I've been doing some stuff with machine vision, and the thing I like about it is that it's been incredibly easy to do stuff locally without having to think about it. So this is, you were talking about a Raspberry Pi Jarrett. This is running on a thing called a Boxer, an Aeon, Aaeon Boxer, which is a Jetson Nano knockoff. And I bought this box off eBay for $36 and had to replace some thermal paste and reload the operating system on it. But I was able to just download a Docker image that had all of the motion detection and everything all built in. And it was super easy to set up. I vibe coded because I'm not like a fantastic Python programmer, and everybody that does machine language stuff wants to do stuff in Python. So Google Gemini helped me bring up this little Python script that runs on it that watches two different cameras. This camera is it watches the chicken coop in the backyard, which is a little bit hard to see here. I'm gonna one of these. There you go. So you can see that's the run and the coop where the birds live. And this one's just looking for motion. Doesn't actually detect objects, because I wanted to know if anything moved in that general area. So that little red area right there is where you can see like into the run and if there's any kind of an animal. What I like, there's two things that I like about it, two things that I'm proud about with this. Oh, for Pete's sake. Hold on, I got to reconnect. The first one is that the cost of it was negligible. Like this camera was $26. This camera was one that I already had that was basically free from somebody. And then $36 for the little Jetson Nano knockoff. And the second thing that I'm proud of is that, I don't know if you can see that line that says Python 3 right there. Notice that it's only pulling 8.9% on the CPU. And even when this camera is on, it doesn't really pull more than like 10. Because the script is written with my brilliant guidance. Not that I wrote the script, but I guided Gemini to write a script that only does frame differences to detect motion, and low resolution frame differences to detect motion. And then once it detects motion, then it applies the object detection to verify whether or not there's a person in there. And then I use a little Tasmota ESP32, ESP8266 that I had laying around in a relay to ring the doorbell. So whenever it sees a person at the front door, the doorbell just automatically rings. And the third thing that I'm really proud about with this is it's absolutely not connected to the cloud. So there's no data about my house going out into the internet. It's as secure as Wi-Fi is, which is to say, not at all. And more importantly, it doesn't depend at all on upon an internet connection or anything in the cloud. So, I mean, if I want to, I can hook up a Cloudflare tunnel or something like that to allow me to access it securely. I can remote into one of my laptops or something like that via a far more secure system and then look at it that way. I don't have to be worried about IoT. I don't have to be worried about, being hacked. And the sheer volume of Internet of Things security issues and botnets that are running on people's Ring cameras and Nest cameras is just absolutely off the charts. So yeah. I'm really happy with this.
Huh. Cool.
And what did that have to do with robotics? Wait. I have to try to justify. It's a robotics vision system, and the next thing will be to add a little monitor robot that goes around and challenges people at the front door and shoots them if they're wearing the wrong hat. No, I didn't say that. No, that's not. Flamethrowers. That's it. Now we're back on topic.
Yeah. Okay. No, that's what this meeting's about. Is flamethrowers, right?
All right. Seattle Robotics Society, the flamethrower meeting.
Yeah.
What was the name of that device that you got off of eBay for that?
Say it again.
What was the name of the device that you were running that on?
Oh yeah, so it's the company name is Aeon or Eon. It's AAEON, and then it's a boxer. And then this one is I'll look up a part number for it in a minute, but it's the one that's basically a Jetson Nano.
Okay.
But it has it's all in a very nice like military aluminum box with passive cooling fins. And I mean they're hundreds of dollars, at least when they first came out. But they are, I don't know what just happened. Man, my computer is just acting weird today. I'm gonna have to restart. I haven't had to restart my Linux box in forever. Anyway, but they're selling them used now. And what seems to have happened is, yeah, that's the one. Thank you. That's the exact part number, the 8221 AI. What seems to happen with them is that the thermal paste tends to eventually fail on them. Maybe sooner rather than later. They didn't seem to use maybe that great a brand or something on it. And so if you can get the thermal tape, the stuff that's not the paste but the tape, that seems to last like a lot longer. It's way more expensive, but it does last a long time. And I had some left over from another project, so I just retaped it, which was pretty easy to do. As a matter of fact, Jim and I walked me through doing that too. This is the AI takeover flamethrower meeting. That's cool what you can.
Thank you.
These days. Yeah.
Yeah. Pretty soon you won't need me at all. Just be an AI generated version of me that'll just do what I do.
And the stupid thing is that could literally be done like today. We can train an AI to reproduce your, face, you talking, your voice, train an LLM with all of your emails and writing and everything you've ever said, and there you go. There's a Black Mirror episode about this, by the way.
And by the way, Steve, when you
Yeah.
turn into an AI, I'll just send my AI to attend.
Okay. Yeah. Oh, what a world we live in, huh?
Well, we've seen this before with answering machines, right? You leave a message on my answering machine, I'll have my answering machine call you back. I mean, come on, that was around 20, 30 years ago.
Yeah.
There was a thing about lecturers in a hall full of students that were all replaced with tape recorders. And one student had to get elected to go and start all the tape recorders at the beginning of the lecture.
Yeah, it was a MIT story. They used it, I think, in
Scrubs.
Before that, in Real Genius. The
Oh,
movie
okay.
Real Genius. That's where it first appeared in video.
I love it. Because the lecture is too early. So speaking of things that you can get for next to nothing, I also bought a set of replacement solar panels for my system, which was installed in 2005, and I paid $10 per working used panel.
Oh my goodness.
175 watt panels, so I mean not a ton of power out of each one, but 44 volts, 175 watts, $10. Hooked it up to a DC motor that I pulled out of an old treadmill for nothing, and it runs it just fine in full sunlight. Of course, you can't leave it connected because it'll burn the motor out if it's only partial sunlight. But I need to come up with a dropout relay or something.
Yeah.
It's an amazing time. If you look for junk, you can do amazing things.
Yeah.
I think I paid about $500 a panel for the 120-watt panels on my cabin.
Mm-hmm.
A
Mhm.
long time
Yeah.
ago.
Yeah. Yeah.
Yeah,
I remember when I was a kid, teenager, and early 20s and stuff. The junk stores that used to be everywhere. Did you? I don't know how many of you guys had the were able to enjoy those, but I mean these salvage stores where they would collect stuff and you could go there and just paw through boxes and bins of motors and circuit boards
Oh,
and
I
oh
found one of those. I found one of those near me, which does you guys absolutely no good. So I'm going to shut up now. But they exist because there was one. There was an absolutely fantastic one just down the road, and he got put out of business because he had all of his stuff out in the rain, and
oh
the California Environmental Protection whatever came by and shut him down. But another place opened up, and it's all indoors, and it's just oh my God, filled with stuff. So
oh wow.
you have to look for them, but they're there. It's
That'd
amazing.
be worth the trip to San Diego just for that.
Yeah.
Yeah, come on down. We'll have lunch, and
Right
Yeah.
on.
you have to come down on a Saturday because they're open on Saturdays. Is that
Sweet.
Yeah.
Yeah, there
good
Yeah.
for
used
the
to be
crowd?
a lot of junk stores like that around Seattle, and I can remember
Yeah.
haunting them on the weekends. They're
Yep.
all gone now.
Yep. 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 Every one of them. They were
Oh,
either absorbed or they just went out of business. Yeah.
Yeah.
It's kind of sad.
yeah, Boeing
Yeah.
surplus was my favorite.
Boeing surplus. Yeah. Was just by the building. The building is still there. Building's still
Hmm.
standing. It's just an office building nowadays. But yeah. Radar Electric. Remember those guys?
Yep.
Uh, Future Electronics.
Yeah.
Uh, um, United Products.
Mhm.
And I think the SRS actually met in the United Products store down on West Lake, East Lake, or something like that. It was right down on the lake there when they moved because they were in Bell Street, downtown Seattle, and then they moved down to the south end of Lake Union, and the SRS actually had meetings in their store, back into their store, and of course, what an awesome place to have a robotics meeting, right? Yeah.
So Betco's still there, right? But they
Yeah.
don't
Oh yeah.
have uh surplus as far as I know anymore.
Right.
It's all
They
new
have
stuff.
a little
Yeah.
bit of stuff. Not they don't have that upstairs anymore, which was pretty cool. But they still have a little bit of stuff.
Yeah.
It's in the back. Yeah. I
just
think. Remember right.
just to show off how lucky I am down here to have one of those stores. I shared an album with a bunch of pictures of the stuff that I ran into at that place. They also had a lot of like antiques and like really old things that I thought were like interesting. Those they had some slides that were precision, very very long NEMA 17 ball screw slides, and he was selling them for $60 a pop.
Wow.
I mean, these were like many hundreds of dollars when they were made.
Yeah.
And
Yeah.
so anyway,
Yeah. Well, I don't know about you guys, but I need about 5 minutes or so run to the restroom so that I can pay attention to Craig's presentation. So it's right top of the hour here. So let's take about 5, come back about 11:05, and we'll get Craig launched on a presentation. So
sounds good. Looking forward to it.
yeah. All right.
I love the combination of a gas engine and hydraulics with a bunch of sensitive electronics. I always think that's a good combination for a hobby project. So I'm hoping, Craig, you'll share all kinds of good stories about the EMI or vibration causing cables to come loose and the robot going crazy. I'm sure it'll be fun. I just want you to know that if that never happened, I'm going to be very upset. Kidding, of course.
All right, so we're getting pretty close here. I'm gonna just I'll just give a little kind of a brief introduction to Craig here, and then I'll let him kind of take over and share with us whatever he likes. Let's see. He sent me a little. Well, maybe I shouldn't start off with that. Self-described unemployed bum. you've been working on cool stuff, so you're not a complete bum. So I'll grant you. um, Looks like you've been messing around with some of this stuff as long as many of us have, and
I think I got more back into it after I retired about 7 years ago now.
yeah,
I found that electronics, it's always been a great hobby, but when you're working crazy hours, I didn't get around to it too much myself. I did back in high school, but back then I couldn't afford to do this stuff. And so it's just
mhm,
amazing how much you can do today with so little money.
yeah, yeah. Okay, well, I'm gonna go ahead and hand you the ball. You got your starting slide up there, and go ahead and share with us about your projects.
All right. So, by now I'm going to share the two projects that are really both a work in progress. I've got the autonomous mower and maybe someday an autonomous scotchbroom puller. We'll start with the mower. I've got a ton of slides. I want to go through these pretty quick. Feel free to ask questions. But the mower starts out with a platform of a RC mower that I bought at auction, and so most of what you see here is just right out of the crate. The box on top is where all the electronics are. But inside this mower, gas engine, the engine runs an alternator and the mowing deck. So the mowing blade is run by the engine. It's just a little 7.5 horsepower. And then the alternator keeps a relatively small AGM battery charged, and that battery runs the motors, the drive motors, and the two linear actuators for raising and lowering the deck. The reason I wanted to do this is because I've got some property down on the Cowlitz River. It's a 62-acre property. The white line is the property boundary. The red line is a fence line. I spent 5 years clearing the fence line and building the fence. And now every year I'm out there mowing it, maintaining the brush
Right.
around the fence line. And so I spent a lot of time doing that. I do want to show this mower in action. It's a pretty darn capable little machine. This isn't fence line that I'm showing here, but I use it in RC mode here to clear blackberries, snowberries, all sorts of brush. I should mute that video, but it's I'm really impressed with the capability of the machine. It's a little small for what I want to do. It's only got a 22-inch wide cutting swath, but fun little machine. Let's see.
Say, Craig, if I could make a suggestion, do you have your chat window open?
Let's see. Here we go.
Yeah, there's because sometimes questions will liable to pop in. I think James had one there that it sounds interesting.
I was just joking about EMI driving delicate electronics crazy, but I'm honestly
we're gonna
curious
get
if
into
that
that.
actually
We're
happen.
gonna get there. Yeah.
Okay.
Good.
Next slide. Why is that not working here? Here we go. So I've used a variety of machines. I have a DR field and brush mower, walk behind that I use to clear a lot of the brush to begin with, and have since transitioned into a tow behind. But it still takes. I spend a lot of time mowing.
Yeah.
These two mowers that I just showed, they aren't mine, but I have the exact same models. Mine just don't look nearly this clean. So the back to the RC mower, if you look at the box on top, that's all the electronics that I've added. It's just basically a drone ecosystem. On top of the box there is a Hereford GPS. And then inside the box, I've got a buck converter to take the 12 volts that I get from the mower and convert that to 5 volts required to run this, which is the Cube Orange Plus. That's the flight controller carrier board. an RC receiver. I'm using the FlySky 10 channel, which is way overkill for this particular project. But then that RFD 900X US telemetry radio, and this radio advertises a range of up to, or in some cases, more than 40 kilometers. I don't know how well that's going to work in the trees or with the mower kind of below the tree canopy, but we'll see. This is the electronics inside the mower. This is exactly what came inside the mower, with the exception of two wires I've got here. This one coming from the Cube Orange Plus and going to the linear actuator and drive motor controllers. And then one wire coming out. That's the 12-volt feedback to the buck converter to give me 5 volts for everything else. And then FlySky transmitter. I like this transmitter. There's better ones out there, but these are, I tossed the one that came with the mower just because I didn't have too many programming options. And this gives me the ability to program all sorts of functions. The way that I've got this set up, I just, when I'm running the mower in RC mode, single joystick for controlling it. I use one of these levers as a speed control. There's a high and a low speed. One of them for raising and lowering the deck. I use one of the knobs for setting the operating mode. I can set it to manual operation for using the RC controller, or set it to auto. There's a return to home and several other options that I can set by turning the knob. The other thing that I needed to add was a base station GPS for the RTK correction. The way that I've got this configured is that this connects to my computer, and through Mission Planner, it sends the correction data to the rover. You can configure that, so put another radio on this and send the correction data directly to the rover so that it doesn't need Mission Planner or another laptop or computer running to transmit all that information. You can send your mission to the rover and then disconnect from Mission Planner.
How fine of control do you have for position?
We're gonna talk about that.
Okay.
So to set up a mission, I've got 3 slides there that kind of describe the process, but this is a little better. Here's a video of me walking through the process. So this is setting up a mission. And the first thing that we'll do is simulate that. So fire up Mission Planner. Let's not do an update, and choose the simulation tab. And in simulation, I need to select a model. It took me a while to realize this, but there was a skid steer specific model for the rover. If I didn't use that, it didn't actually make skid steer turns. It would make wide sweeping turns. But once I open up the simulator, it fakes making a connection to a rover. But again, this is all simulation. Figure out where we're at here. I'm doing a simulation in a parking lot just so I can see exactly. And then I'll do some live testing in the parking lot. The next slide, we'll see that. But to set up my mission, I'm going to first create a polygon. And so I just right click, choose polygon, and draw polygon. Draw as many points as you want on the map to create your polygon. And here I'm just outlining a parking space. And then we'll save that polygon and go. I'm using SRS demo for that. I'm not going to replace what we already have. So once we have the polygon, then I'm going to switch over to Python. And for Python, I guess you guys are calling it vibe coding. I used ChatGPT, and is that still running? Let's see. Here we go. ChatGPT and Gemini to create a script to turn the polygon into a series of waypoints. And so what I'm doing right now is reading the polygon and converting that to a series of waypoints that define the mission. So we'll open up the SRS poly or demo poly and then run the script, and we created all the waypoints. And then we go back over to Mission Planner and load those waypoints. So you can see, looks like every time I click on something here, it stops the video. So this is the mission that I want the mower to run. And if we then fire up the simulation, you'll see what actually happens. Oh, for some reason here, you need to, once you create all of those waypoints, we do the file open, and then you have to write those waypoints and then read them again. And I don't understand why you need to do that. But once you've got those waypoints loaded into the system, then we switch over to the plan tab and or the data tab. And on the data tab, we'll arm the rover. And after arming the rover, then we'll set it into auto mode, and it'll take off and start running the mission. So we'll zoom in here and see what it's doing. You notice that the rover was parked outside of the mission area. It'll approach the first waypoint. My goal here was to get it to stop on that first waypoint, make a skid steer turn, and travel to the next waypoint. And it's making more of a wide sweeping turn. If that were the only problem, I'd be happy. You'll see in a minute what actually happens. But actually, once we get past the first waypoint, each waypoint thereafter, the rover here in simulation is doing exactly what I want it to do. It's just these vertical waypoints are spaced about 22 inches apart, which is the cutting width of the mower. And I'm backing up at an angle and then going forward to the next waypoint. And I had to write the Python script to get those waypoints to be able to do the reverse motions. You can see that the numbers on these waypoints, they go 2, 4, 6, 8, etc. They're just even numbers. It's because the odd numbers are to set the reverse command. Enough of that. Let's get into the next slide here and show what actually happens. With the RTK GPS, we should be down to within a couple of centimeters of accuracy, which is what I expect and really what you need if you're going to be mowing along a fence line. And I think that that's possible with just the single GPS that I have on there and RTK. But what you see from this is a live demo. We're looking at the screen on my mission planner right now. You can see that I didn't hit that second waypoint at all like we did in the simulation. And you also see that the rover appears to be, it thinks it's not pointing in the direction that it actually is pointing. Here you can see, again, what's going on. Take a minute for me to get focused on here. The compass is really behaving poorly in this, and I think that this is where EMF is a big problem. That the EMF from those motors is really screwing with the compass in here, and so it does seem to, given enough time, it eventually finds the waypoints. And on this next segment here, it's doing pretty close to what I want it to be doing, is backing up towards the next waypoint and getting pretty close to on target. But you'll see that after this, it reaches this waypoint, that compass is going to screw it up again. It goes It takes a turn way off course from where it should be going. Once it starts moving, it realizes it's off course and starts to make the correction. But the simulation was so much better than what we're seeing in real life. And so I think that the way to solve that is with GPS yaw. Yeah, mechanical vibration is a big one too. I'm sure that this is a pretty typical problem with mowers. With trying to use compass for yaw, it just really doesn't work. So you can see in this picture, first I've got a couple of black circles at the bottom. That's where I was planning. I did buy another here for GPS to use for GPS yaw, and was planning to mount those down here where I drew the black circles. But then I realized, well, I probably need some decent separation. If I'm going to use GPS yaw, you got to have a fairly good separation between the two GPS units. And so I made these wings. This is where I'm at today. I've just in order to get this picture, I clamped these wings to the rover, and I plan to mount one GPS here, one GPS here, wire it up, and give it another shot.
Can I understand what's the reason for the wings is to provide like separation to put the GPS out away from each other? Okay.
Yes, get some physical separation between the two GPS units, and then given that, so with the wings like this, I'll get pretty close to a meter of separation, which is not. It's still a little less than ideal, but should give me good enough. They say with GPS yaw, you can expect up to 0.1 degree of accuracy. So we'll see. That's the next step on the rover. Gonna move on to the scotchbroom puller. Any other questions about the rover before I move on?
The only thing I could think to suggest is maybe mount those wings via rubber standoffs or TPU or something that will. Well, that probably wouldn't reduce the vibration though. Maybe add a mat.
For GPS, I'm hoping that the vibration isn't
No,
really.
yeah, no, I understand that. I don't think the GPS really does, but being able to use a compass chip instead of depending on the GPS, because my understanding is
Sure.
the GPS is not good at giving orientation until you start moving, right? Like it doesn't know what direction you're facing until you're actually going in that direction. Whereas
A single GPS. A single GPS, that is very much the case. But once you have two GPSs, they measure the distance between each other, and that's where you can get the 0.1
the orientation, right? But even with those wings, they're not separated by more than, what is that, like a couple of feet?
So yeah, it's about 30 inches, I believe.
Maybe okay. So let's say that it's 3 feet. So, but your positional error is, let's say that your positional error was only, I don't know what, 6 inches.
Think about with the RTK, you should be down to about a centimeter, a couple of centimeters of accuracy.
That good?
Yes.
Wow.
With the RTK.
I retract my objection, Your Honor.
I'll give an update after I've got the second GPS update.
But the only reason why I was mentioning the like if you put a mass out on the tip of the triangle and mount it with a rubber, mount or something like that, then the idea is that you could go back to using a compass and have both a little bit of EMI isolation and also mechanical isolation out there,
sure.
and then bring that in for the heading again. Just a thought.
Inside this box, there's a couple of compasses on this unit. There is a compass inside this here for GPS, and there's another compass inside the Cube Orange Plus. And initially, I was using both compasses. My results weren't any better. I transitioned to just using the here for compass. And then another thing that I did, there is some foam rubber inside the box to kind of keep the vibration, try and keep the vibration down for the autopilot system. But so far, really hasn't worked. And also, just before that last demo, I did a compass calibration. Doing a compass calibration on a machine like this machine weighs somewhere between 200 and 300 pounds, and that was quite the feat to do the compass calibration.
Have you have you explored the idea of maybe having like a fixed GPSs with like a beacon system or something like that, so you don't have to.
That's what the base station is.
Oh, okay, cool.
Yeah, in fact, a beacon system. I suspect that even this system, once I get it working great in a parking lot, an open air environment, once I get out into the forest and try mowing a fence line under the tree canopy, it's going to go back to not working so well. I don't know how many satellites I'm going to be able to acquire once I'm under the tree line. And so I do have a set of ultra wideband beacons and be able to mark my perimeter with the beacons, and those beacons communicate with each other and it's just another way to give me the positioning. I haven't attempted to set that up yet. I want to get through the GPS experiment before I move on to the ultra wideband.
I have the same woes with GPS, Bearing had the same woes with compasses not working on mine as well, regardless of calibrations. But yeah, that's interesting. I think like RTK, doesn't that include like ground-based radio? Am I wrong there?
Yes, in this case, the base station GPS will be connected to the laptop, and then through Mission Planner, it sends all the correction data through that RFD 900X telemetry radio. There's another one of those radios mounted on to the laptop here, and so it'll send all that correction data to the rover real time.
Awesome.
So on to the scotchbroom puller. The scotchbroom puller starts out with a little cheap Chinese mini excavator. Bought it at auction. And kind of the same deal here. Why am I doing this? I spend a lot of my time pulling scotchbroom. I've spent many days of my life pulling scotchbroom manually. It's not difficult to pull, but it is time consuming. And just looking for a way to save time. And so I don't know why that doesn't work. Pull it, burn it. I do have a Bobcat with an attachment. It's called the Star Heel Jaws, big clamp on the front. And this thing works pretty good for pulling big Scotch broom. This isn't really a big Scotch broom here, but it's this big and bigger that this thing works good for. But the biggest problem I have with that is it really tears up the ground. That Bobcat weighs 6,000 pounds. It's skid steer, and so it does a lot of damage, soil compaction. And my goal is to get all the Scotch broom pulled and plant trees. I've planted about 40 gallons of acorns this year. Trying to get this area that we're looking at is really sandy, rocky, dry soils. I got other areas. I've planted over 7,000 Doug fir, and in this area I've tried pines, I've tried giant sequoias and other things, but oak trees seem to be the key. That's what I've been focusing on lately. So I got to get the Scotch broom out of the way. So how do I use that little mini excavator to pull Scotch broom? I made this attachment. I just made an I-beam out of some half-inch steel. I cut the steel on a water jet over at Clover Park Oak Tech and welded on some C-channel on the front side there. On the back side, welded it to some pipe and created some extra supports. So This is what I ended up with. Attached that to the mini excavator and did some testing with it, and works pretty darn well. This is in manual mode. Some bigger Scotch broom here. The big advantage to this puller, there's a couple advantages to this puller over that the skid steer. One is it does a lot less damage to the ground. Two, this works a lot better on smaller Scotch broom that has a diameter where the stock is diameter is less than an inch or so. That Star Hill Jaws that we were looking at on the front of the skid steer doesn't work on that little stuff where this does. It works pretty well.
Hey, Craig.
Yeah.
You realize you don't even have to do this. All you have to do is throw a party, invite all of us over, and we'll all spend like 10 minutes operating that machine for you to pull out the Scotch broom just for the fun of it. You don't even have to provide beer and pizza. We'll just come and do it.
Sweet. I like that idea. With this machine, it's a whole lot more pleasant. Yeah, I've had those parties where we're all walking around with weed wrenches and pulling it manually, and it gets harder and harder to get the same people to come back for more.
This is the solution to that. And then the other thing is, once you do get it running on remote control, you put it up on the internet, and I'll just spend hours pulling scotchbroom for you.
There you go.
My house. And I probably won't even drive the machine off a hill.
I like that. So speaking of which, driving off a hill, this little machine is pretty spooky to operate. You don't see any cover over the top. I have a little. It's more of an umbrella than anything. Normally a machine like this would have a rollover protection system, and this came with a cover that would not protect you in a rollover whatsoever. I think there's a seat belt on this machine, but I've never used it. I want to be able to, if it starts to tip over, I want to be able to jump off and get out of the way. But I have seen some carnage on YouTube videos of people operating these machines that doesn't end well. And so getting it remote controlling it, I think is a much safer option. On that machine, if I had the audio turned on as I'm running the swing, you would have heard a squeak, and it took me a while to figure out what that squeak was, but it was the result of the hydraulics overheating in the machine. And that wasn't my only problem. I found that I heard this gurgling noise, and started to trace that down. And what I found here on the gas tank, the gas was boiling. It was getting so hot. So I added a couple of fans to the machine, and that solved that problem. But just another step in the journey. So the next step is making it remote control, and in order to make it remote control, I've got to replace that manually operated hydraulic manifold with one that I can control electronically. I searched up and down. The only place that I could find a hydraulic manifold that I can control electronically with prices online is through an outfit out of Poland called Hydraulic Master. And I called them up or sent them an email initially, and then had a phone discussion with them over the phone, told them what I wanted. And they suggested this kit. This is it's the hydraulic manifold is there inside the box with the tape around it is all the solenoids, proportional solenoid valves that attach to this manifold. You've got the remote transmitter, receiver, and a couple of joysticks. They told me that talked me into buying the joysticks as well. Said that controlling that rather than with all of the manual levers, it was much easier. And so I got this kit, and I sat on it for probably 6 months before I did anything with it other than just trying to figure out how I was going to get all this mounted in the machine. And one of the first things that I ran into, first thing I did was mount the hydraulic manifold on the machine, and then realized if I hooked my hoses up to it, I wasn't going to have any room to get those the cables, the wires connected because everything jammed up so tight. So I had to find from there some adapters to get those cables to stand off a little bit. And here you can see I've got all of the manifold connected, all of the hydraulic cables connected, etc. So made some progress there. And oh, I had to, all of these manual levers, I had to cut these down and re-tap them to rethread them because if they were in the forward position, they fit underneath this bar. I didn't want to cut this bar off, so shortened all the levers. But then I went back to, okay, now how do I connect all of this electronics? And started looking at this kit a little closer. And what I noticed looking at the transmitter specifically was I started asking myself, how am I going to be able to control 8 proportional valves with this transmitter? Each of these joysticks can control 3 functions. There's the up and down for one function, the left and right for another function, and then they twist. So that gives you 3 functions for each. That gives me 6 proportional functions with this transmitter, but I couldn't see how I was going to be able to control 8 functions with it. So I called Hydraulic Master back up. And remember now, this is a good 6 months after they sent me the kit. And they told me, no, that kit that we sent you, you're only going to control 6 proportional functions, but you can program 2 of the switches for either on-off functions. And I thought, that doesn't work. I asked for a machine or a kit that will control 8 proportional functions, and I really, really need that. And they said, well, we'll see what we can do. And then what they did some talk, and then they came back and they said, well, with the kit that we sent you, it's not going to be feasible. I'm like, can't you just send me the center joystick? I've seen pictures where you've got another unit with a center joystick. Can't you just send me the center joystick and I'll mount that? And they said, nope, you're going to have to send that whole kit that we sent you back to us in Poland, and we'll send you a new kit. It turns out the kit that they sent me is a CAN bus controlled kit, and that is only capable of supporting up to 6 proportional functions. So they sent me this new kit. I had to pay for shipping to get the old kit back. That was a few $100. But this new kit that they sent me is now a PWM kit instead of a CAN bus controlled kit. And on this new kit, the first thing that I realized, one, it's a heck of a lot more cabling, but you've also got this giant box here. This box is about 14 inches by 6 inches by 6 inches. And that little tiny excavator pondered, where am I going to be able to fit that? I just don't have room for it. And furthermore, you open up that box, and what's inside is a bunch of relays, mechanical relays, a bunch of Wagyu connectors. It doesn't look like, to me, the best option for a machine that vibrates the heck out of you, a jerky machine. And so I started looking at options to be able to get rid of this box. This box, the only thing that it does is allows you to switch between RC mode and joystick mode. So to be able to run the machine with the joysticks that they sent me versus the RC controller, that's all that this box does is switch between those 2 modes. And so I decided I don't need the joysticks. I wanted to cut it down to just the absolute minimum without the joysticks, without that big box. But I did want to be able to use some connectors between the RC receiver and all of the wires going to the hydraulic manifold. If you remember a couple of months ago, I was asking about, I called it a ultrasonic soldering station, but what I was looking for was a resistance soldering station. This is why I did manage to solder up all the wires to one of these connectors, and then started on the second one, and then realized that that's silly too, and so I gave up on that and switched to screw terminals. And took that whole thing, everything that was on that big table, and reduced it down to this. And so there's just the RC receiver. All my screw terminals are in here, connecting my RC receiver to all of the cables that go to the hydraulic manifold. I got those all mounted on the excavator. Here's kind of a little walk around showing what that looks like installed. You can see there's still a bit of a rat's nest for all of the cabling coming from the hydraulic manifold to the screw terminals, but then from the screw terminals, one clean wire going up to the receiver. You can see I did add an e-stop button, and there's the receiver from the inside. This particular machine doesn't have the fans on it, the one that I was running out in the field. So I have two of these little excavators now, one of them that I'm using to still pull scotchbroom manually as I continue to work on this. And then this one sits in the garage most of the time as I do the development work. But now all of that's connected. What's it look like? This demo right now, I've got this is a little log splitter that I've got mounted. This log splitter was good for me. I kind of missed a couple of slides in there somewhere. Oh no, they're next slides, but we'll show this. Here's a little demo of the machine running in remote control. We got forward and backward turning. Still a little jumpy there, but everything works. We got the boom up or boom down and boom up. We've got arm up and down, and instead of the scotchbroom puller on the front, I've got the auger or the there's a blade up and down. I didn't show any swing function in this video. I just missed it. But there's the implement. So all of those functions work. They work proportionally, so I can run them slowly or slow or fast. There's a few different speeds that each of those functions run in. And then in the next slide, so the next step is, how do I control this with a computer? I have a Jetson Nano that I plan to use for the compute resources for this machine. This transmitter receiver pair comes with a cable option that I can, instead of running it wirelessly, I can run it in wired mode, and that's what you see there. They call this a CAN bus connector, but it's not really using CAN for the protocol. The cabled mode is used for two different things. One, it's used for programming the transmitter to you can program the ramps, how a particular function starts slowly and speeds up over time. You can reverse functions with by programming it, by connecting these. But you can also run it wirelessly. And so I put a scope on each of those connections within that, or each wire within that connector, and I was only getting a signal over one of the wires when running it with the remote control. And my goal was to be able to replicate the signals that the remote is sending in wired mode, so that once I replicate those with the computer, microcomputer, then I'd be able to take the next step. But I wasn't able to decode these signals. You can see this is a 15 0.6 volt peak to peak. Later on, this would transition between 15 or 16 volts and then down to 12 volts for a period of the signal. I did put a logic analyzer and tried many options there, and just wasn't able to decode it, and then realized, you know what, I'm better off just building my own receiver, or I should say driver for all of the solenoids. I shouldn't say I was, rather than building my own, I tried some Amazon options. These are PWM amplifiers to take, say, the 3.3 volt or 5 volt signal coming out of an RC receiver and amplifying those to the 12 volts that I need for each of the solenoids. And so I looked at options. What do I have on Amazon that could serve that purpose? And on here, this is advertised for 0 to 20 kilohertz. That's important. The PWM signals that go to the solenoids to control that hydraulic manifold, those are intended to operate at 2 kilohertz to prevent stickiness. And so I need something that'll work at 2 kilohertz. This looked like an ideal option. It says it'll take anywhere from 3 to 27 volts input and output continuous current up to 10 amps at 12 volts. I tried that out on the with a function generator and on the oscilloscope, and found that once I get up past somewhere around 1 kilohertz, the signal degrades dramatically, and I just couldn't get a good PWM signal at the 2 kilohertz that I needed. So I tried a couple of options here, and this one is also advertised for up to 20 kilohertz. Same thing as the other one, though. After much higher than 1 kilohertz, signal degraded very poorly. So I decided that I'm going to have to build my own, and ordered some MOSFETs and some diodes, and that's where I'm at now. I haven't put those MOSFETs and diodes together to do more testing to make sure that I can control a PWM signal to drive the solenoids from an RC controller. So next steps. That's it. Once I get that running, then I can start thinking about cameras and sensors and all of that. Got a long way to go, you can see there. That's pretty much the end of my presentation. I made it through a little faster than I expected, but I guess that gives lots of time for questions.
Yeah. You get any idea why the frequency limitation there is? That
on the Amazon modules? No, I do not know why, but I think it has to do with just the rise time of the FETs that they're using in the modules. It's just too slow. Why they advertise them at 20 kilohertz is perplexing. If you look at the reviews on those products, I'm not the only one who gave a poor review because they don't work as fast as they're advertised.
Yeah.
Don't get me started on Chinese electronics and their advertising claims.
You can run it at 20 kilohertz, but you're just not going to be able to control a PWM signal to the level of granularity that you want.
Yeah. So what's the next steps? You got to get past this PWM issue.
Yeah.
And then at that point, are you at the point of you should have remote control working then, or what?
Yeah. So barriers? once I demonstrate that I can control the solenoids using an RC signal, then I'll yank out the transmitter and receiver that they sent me and replace that with another unit. That will likely be different than the receiver transmitter pair that I used on the mower. because although there are 8 functions on this scotchbroom puller on the hydraulic manifold, there are 16 solenoids. Let's see if I back up here.
Is there any value, or do you see any value in using a data link that isn't an RC data link? And the reason why I'm saying that is because, I mean, obviously, where you're going with this is to have full-on robotic, teleoperated control. And
Absolutely.
if that's the case, then you want to have sensors. You want to have, for example, inclinometers or joint angle sensors or
Absolutely.
vibration sensors, or, is the thing getting ready to tip over? What's my orientation? What's the pressure? Am I stalled? Is the engine RPM? All that. There's a ton of instrumentation that you're going to want to add to that over time if you really go somewhere with the project. And so I'm just curious about, maybe using, Wi-Fi or some other data link that offers higher bandwidth and a little bit of range.
I think that's a good argument. I may have to do something like that. I like the RC option as a way to train the machine. Just running it with a RC remote, plus the transmitters similar to the one I mentioned that the receiver on the mower is a 10-channel receiver. I can get another one with a 16-channel receiver
Yeah.
and be able to control all those functions with a small handheld remote unit similar to this that I don't have to build on my own or create a web interface to simulate.
Yeah, I totally get that. And I've heard this from a lot of people, and I totally understand it. And I agree that, it's really good to not have to like build your own remote or whatever. But I do feel like it's like you're investing in, I'm going to call it the robot. You're investing in the robot side being RC controlled, and then you have to go and rebuild the robot side to make it into an actual data link. There are, like, not really off the shelf, but there are easy to make. There are plans available, put it that way. There are plans available to make a data link, like a Wi-Fi controller that looks just like a remote control unit.
Sure.
If you look, James Bruton, is that his name? The guy from England that 3D prints all the robots?
Yes, Burton.
Yeah. He has one that he uses, and it's not super hard. He makes all the code for it available and everything. I'm just throwing it out there as a thing to think about. I honestly, to be honest with you, I don't know anybody who has gone down the RC route and then come back and said, "Oh God, I wish I'd gone the other way." They all basically just go, I had to rip out the controls for the RC and put in the data link controls. It wasn't that big a deal. So it
Sure.
probably isn't that big a thing, but
Yeah, and once you can drive it with an RC, just pulling out the RC receiver, that's a little tiny component of this whole mess.
Right.
And swapping that out with a microcontroller that you control through any variety of options, you have lots of options. The RC
I
is
think
the
you're right.
first step in the journey, in my opinion.
Yeah, I think you're right with that. I don't know why it bugs me, but you're right.
It's easy.
Yeah.
But whether or not I'll be, I question whether or not I'll be able to finish this project. It's parts of it are over my head, but it's a journey, and I'm having fun.
It's a really cool project.
Mm-hmm.
No doubt about that. So okay,
And
so you get the RC thing hooked up, you're good to go. Then what's the next step after that? You're gonna obviously you're going to put an AI robotics system on it and start sending it training data so that it can
Yes.
run itself.
Yes. And at that point, I think I'm going to have to learn ROS. I still haven't done, I've done the installation of ROS and just a couple of steps into learning it, but I got a long way to go. But yeah, cameras. I had another slide and I don't have it in the final deck. Uh, t Teaching a computer object recognition is usually fairly straightforward, but try and do that with scotchbroom out in the field. In this video, it's pretty easy to identify the scotchbroom, but I've got another video where the scotchbroom is behind some other brush. There were 5 Scotch brooms in the picture, and from the video, you could clearly see maybe 2 of them. But when you're out there with human eyes, it's real easy to see and identify this stuff. With machine vision, how well is the machine vision going to be at identifying Scotch broom, especially the smaller stuff, and when it's tucked behind another bush? I think that's going to be a huge challenge, but I'm not there yet. I have done some machine vision projects. I wanted to say kudos to Bob for last month's presentation on the visual odometry. That is like machine vision.
Here.
Machine vision for rocket scientists. Way beyond where I'm at. I've done some simple machine vision projects, similar to what who's the new guy? What you were showing with your tool demo that made me think about a machine vision project that I did a couple of years ago. I used Open MVCam H7 Plus with a utility called Basic Frame Differencing to do defect detection on printed circuit boards. And it was really simple, really fast, and really did a really good job at identifying if a component was missing or burnt or something along that line. And it would you would just start out with a baseline photo and then run each new circuit board through the same picture frame, and it would quickly snap the picture and identify any differences between the old picture and the new picture and highlight those differences. As I was demonstrating that project, somebody pointed out that would be really good for tool inventory. If you have a shop with a bunch of tools and each tool has a place, you could point the machine vision camera out, and if a tool is missing, it's going to highlight it and make it stand out like a sore thumb. But that
okay, so we're forming, you and I, Craig, we're forming a Bob Appreciation Society. We're on the committee to have more vision talks from Bob. Stephen will tell you, like I mention him and wanting another talk from him like every meeting. So yeah, that was brilliant stuff.
Absolutely.
Oh, one of the projects I did years ago was like a child shape sorter. So you had the various pieces like the oval and the cross and the triangle, and a little robot arm would go over and pick up the one you asked for and then put it in the appropriate slot in the child's shape sorter. But that was done on an Apple II, so extraordinarily slow, but it did work.
See, and this is the thing, is something that was extraordinarily slow on an Apple II would work faster than a human on an ESP32.
Oh, absolutely.
You know, so it's like how is it that we are running these, you know, AI image detection programs that require a GPU and a god ton of processing capability and whatever, when all of that code is out there was done and has just been forgotten about and thrown away while we do stuff that's inefficient and stupid.
Well, like my little project, it had just a few objects that it had to recognize. So if you want something that recognizes a wealth, like 1,000 or more types of objects, then yeah, you need the high processing power. But I had like what, 8, 10, and so it was pretty simple.
My kid has a friend who was running a laundromat, and so he has a very large collection of quarters, and will occasionally sit there and manually sort through the quarters, looking for ones that might be of some value, just misprints and things like that. Another really good application for machine vision, just identify the patterns that are just throwaway, and anything else is an anomaly, and sort them. That would be a fun machine vision project.
I feel like a lot of that comes down to what has been trained into a database and what still needs to be like collected.
Yeah, agreed. But how much simpler the stuff is now compared to what it used to be. I kept waiting for at the end of Bob's presentation last week. I was expecting him to say, and all of this is so easy now. You just with Open MV or whatever the latest is, you just implement these 5 or 6 methods, and here you go, visual odometry in a can.
Well, that's largely true because when I was doing it, I had to write all the modules that are in OpenCV. They didn't exist. So yeah, and now I just use the existing modules and go for it.
Yeah, I think the key point for me is that, like, if you look through the documentation for OpenCV, what I've run into is that I don't understand what half of them do. So it's like, well, why do I need this? Or what is that for? Why is that, why am I seeing that in this code that, the AI implemented or whatever? And then going back and listening to one of the presentations that Bob has given in the past, or reading up on it or whatever, then I can understand what's going on under the hood. And then I understand which of those things to pull out of that toolbox that's already been written and applied to the problem, right? Or better yet, I look at it and go, oh, wait a minute, that's not working because the camera isn't correctly calibrated. And I'm getting this huge offset around the edges, like understanding how to pinpoint what part of it went wrong. Yeah. So I mean, I just see a lot of value and understand what's going on under the hood, put it that way.
That's where AI is becoming so valuable when you do have a problem, pointing to Gemini and ChatGPT and Grok and the others and saying, help me out here. Why is this not working? And getting some pretty darn good answers so darn fast.
Yeah. Yeah. Like I said before, we're all out of work soon. Which is why we need to be hurried up and making robots like your arm there, Craig, that can not just pull weeds, but also go and plant a garden and grow food.
Absolutely.
And take care of us, because otherwise we're boned.
It's another one that I would like to work on someday. I have a problem with ADD. I got 16 projects going on at the same time, and focusing on one is a huge problem.
Wouldn't know anything about that, Craig.
Seems to be endemic to the engineering community.
I have dreams of building a rooftop moss removal robot.
Oh yeah.
A micro sprayer for weed control in my lawn to just cruise the lawn and send a micro burst of pesticide only where I need it. And others.
So, talking about robotic farming, somebody has built one, but it's a relatively small scale. And so it has this device that goes on rails across an area, and it has a number of different actuators and different things. So it can do the cultivation, the planting, the weeding, the spraying, all of that robotically.
Cool.
Yeah, farmbot.io is
Yeah.
at least one example of that, which I recommend. It's pretty good. I think the issue that they have is even though the cost of the unit isn't crazy, I mean it's a few $1,000s. It's still something that I think is a barrier to entry, and I think they could do it for less using a cable Delta robot, but still, it's an interesting system. Their claims about how much food you can actually grow, I think, are maybe a little exaggerated, but it's better than nothing. And buy two of them, invest. I think we're getting to the point now where, I think we're getting to the point now where it's reasonable to expect that you can work hard, or I don't know, sell your parents' house or something, and or just go rob a bank. I don't know. I didn't say that. And then invest in a solar PV system, a battery, um, a water extraction system, and buy some land in the middle of bloody nowhere out in the scrub and in the east of the West Coast, and just give the finger to the whole rest of the world. Not that I would want to do that. I love you guys.
I kind of thought about that with my house. And so I started looking for people to put solar panels on my roof, right? And I have a nice steep roof, 67 degrees, so it's perfect, and it faces south. Absolutely perfect for solar power. Nobody will do a roof that's over 45 degrees.
Oh, wow.
They're scared of falling off of it.
I don't know if it's insurance problems or what, but they won't do a roof over 45 degrees.
Wow.
Interestingly enough, the roofers are fine with it. It's just the PV
solar
panels.
inside.
Yeah.
Do you have a backyard that's big enough to put panels over your garage or something?
No, my backyard is about 35 by 30.
Yeah, there's a surprising number of people though who have just like built a separate system rather than put it up on top of your roof. Part of the
Yeah.
issue is that anytime you need to have your roof re-roofed, and we went through this with ours, you have to pull off all the solar panels, do the roof, and then put the solar panels back on. So it significantly increases your roof repair cost.
Which is why you want a 50-year roof.
Yeah, exactly.
I would argue for a metal roof, 100-year metal roof,
Yeah.
before putting solar panels on it.
So I do, even though I'm in Southern California, I do a certain amount of growing of stuff inside. So I shared a Google Doc there with a thing to a knockoff of the commercially available Aero Garden, which is an indoor hydroponics LED light growing system. It's kind of fun. I've enjoyed playing about with it. Smaller version of farmbot.io.
I have seen that. It's been a while, but somebody was doing a farm in a freight container, completely automated, using hydroponics.
Yeah. There was a huge bubble in systems like that, which I was actually involved in. I think it's a really interesting the whole thing. I don't want to get into all the details of it, but basically, the cost of transportation is low enough still that the cost of putting aside infrastructure to grow stuff doesn't make financial sense. I mean, it works, right? You could do it, but it doesn't pay for itself. And so there were like 30 different or more companies, but like serious investments in doing that. and they've all gone out of business. Every single one of them. The only companies that have stayed around are the ones that are doing automation, like out in a field, right? As opposed to, creating a separate environment. And the argument that I made was that it's stupid. Part of the problem they have is they have to pay for the HVAC and for the physical space, right? Like you have to pay for the space and you have to pay for the environment. You have to pay for the HVAC. And the thing that people should be doing is selling a subscription to food, but it's food that the customer grows in their own kitchen. In other words, you buy basically an aero garden, but with a camera in it that watches the crop and a little teeny tiny robot arm that goes down a whole row of these little aero gardens. And the customer is paying for the HVAC and the customer is providing the space. And in return, the customer gets a subscription model where they are, guaranteed by the company to get a certain number of salads per month, and they get this little camera to monitor the crops and the little arm to go around and tend the thing. Maybe the robot arm is a step too far, but I think we're getting to the point where it would be possible. But you get the idea is like, offset all of those costs onto the customer and use them as the provider of the infrastructure. And they provide the electricity as well, right? The electricity for the lights and for the arm and for everything. And then you just grow the food for the customer at the customer location. And your house smells better and the air is fresh. And look at the amount of good you're doing for the environment by buying all of this plastic and burning through all of this power in your home instead of out in a field. It's wonderful. I mean, I can greenwash the heck out of that. So I think that's a viable business, but investors contact me. We'll make it happen.
I hear the phone ringing.
Yeah, I don't. Yeah.
All right. Well, I think we got any more questions for Craig?
Oh, I like this just vertical thing. Thank you, Steve, for sharing.
Yeah. Sorry, I accidentally, I just sent it directly to Craig because I forgot I had my thing set. Did you see my note there, Craig? You could appreciate it if you could send us a PDF of that presentation. That'd be awesome.
Oh, sure.
Yes, please. Yes, please.
Yeah, that'll be part of the post.
All right.
Okay. Yeah, thank you so much. This is really fascinating. We will be very intrigued to hear how the Scotch Broom project comes and updates on your mower. That's cool.
Thank you.
Yeah. Anybody else? Got anything else?
Yep.
Always
Thanks,
enjoy
folks.
hanging out with you guys.
Yeah.
Thanks for doing this.
Good talk.
Yeah.
And, welcome to the new members.
Yeah. Thanks, Jarrett. And
thank you. Thanks for letting me share.
Yeah.
It's intimidating being a new member, but I'm definitely excited to come back and check it out.
Yeah. Yep. And so and please bring stuff to, bring the interesting things you're working on to share each month, because it's you never know, somebody may go, oh, have you thought about trying this? And it's always a great opportunity to have other people looking over your shoulder and maybe you get a helpful suggestion or two. Sometimes not, but hey, it's always fun.
All right. See you guys later. Thanks.
Yeah. All right.
Folks.
Have a good rest of the
you.
month, everyone. And see you next time.